Hey guys, now that we have discussed a lot about SQL injection attack, it is time for us to talk about how can we defend against such attack. There are two fundamental defenses: sanitize or validate user input, bound parameters. In this technique, there are two kinds of methods: filtering and escaping. In filtering, there's a blacklisting approach and whitelisting approach. Blacklisting approach. It checks the user input whether it contains special characters. If it contains special character, throw away the user input. And that is what blacklisting approach is about. In whitelisting approach, there is a whitelist of valid user input. And then if the input entered by the user does not belong to this whitelist, then again, throw away the user input. So this works slightly differently: blacklisting approach and whitelisting approach. Escaping approach. Escaping approach does not throw away the user input at all. Instead, if the user input contains dangerous characters like quotes, single quotes or double quotes, it will replace them with encodings so that such dangerous character cannot modify the SQL syntax anymore. Because earlier we discussed that SQL injection attack involve injecting dangerous character so that they go and change the original query syntax. But when encoding are applied, those special character are not able to change the syntax anymore. Instead, SQL interpreter will simply interpret such special character as a literal value. So technically, what happens is that when you apply encoding, you simply go and apply a slash or any other escape character as a prefix of the special character. This is a way of telling the interpreter not to interpret this special character as SQL code. Only treat this as a SQL data, simply a data, not as a code. Essentially, it means that special characters cannot modify the SQL query syntax anymore. And that's what escaping is. The last kind of method is called bound parameters, which is known to be the most clean solution to the problem because it addresses the root cause of SQL injection directly. SQL injection is possible because user inputs are being treated as SQL code. If the user input can never become SQL code and only always treated as data, then it addresses the root cause of the problem. And bound parameter does exactly just that. Additionally, you can also take precautions like avoiding verbose error messages when there is an exception or error when SQL interpreter interprets the SQL queries. Then don't show such error messages to the user and expose some kind of sensitive information about, for example, like the syntax of the query, SQL queries, and so on. Also, only apply least privilege principle. That means that even if the SQL injection happens, when the user is given only the least privilege, then there is only a limit to which the user can do. Now, let me demonstrate with a concrete example. This is our running example that we use when we conduct the SQL injection attack earlier, when we talk about the SQL injection attack earlier. So now let's talk about the defense. Let's start with filtering approach, blacklist filtering approach. So here, originally, the user input is used as part of the SQL query. But now, let's apply the filtering approach, blacklist filtering approach. So here, what is happening here is that it checks whether this user input, user and the password, contain a special character called quotes. So this is a PHP building method that checks the presence of special character code. If it contains, if either this one is true or this one is true, then this code will be executed, which says that it is an invalid input. So if this is an invalid input, we will not proceed to execute this SQL query anymore. Instead, we will only return the HTTP response saying that you provided an invalid user input. And this approach is known as blacklist filtering approach. Whitelist filtering approach is slightly different. Instead of doing this, let me comment this out. Whitelist approach will declare a whitelist. So here in this example, it declares a set of valid usernames. And then it checks against the user input here, whether this username is in the list here. So this check whether this user value it is inside this array called whitelist variable. If it is not in the list, then it is considered as an invalid input, and then we will not execute, the program will not execute this SQL query. And this is known as whitelist filtering approach. There are problems with both blacklist filtering approach and whitelist filtering approach. In whitelist filtering approach, it is known to cause false negative. That means there can be other kind of special characters that can also cause SQL injection, not only single quotes. There can be other kinds of characters. So since this approach only checks the presence of single quotes, then SQL injection attack containing any other kind of special character will still be accepted. And then it will miss the SQL, such SQL injection attacks. So those are called false negative. Alternatively, conversely, whitelisting approach is known to cause false positive. Why? Because it will reject inputs that are not in the list. What if the input is still valid but not in the list? Then your input will be rejected. And that is a false positive because that is not an attack. It is just that your input is not in this whitelist. So generally, this approach is considered more secure compared to blacklist approach because blacklist approach will miss the actual SQL injection attack if those attacks use different kind of special characters that are checked here, that are not checked here. On the other hand, whitelist approach will cause false positive because it will reject even valid inputs as long as they are not in the whitelist. So both have a trade-off. Which one to use? It really depends on your system requirements. Sometimes false positives are preferable. Sometimes false negatives are preferable. But in generally, from the point of view of security, first, we don't really want false negative because this will miss actual SQL injection attack. But on the other hand, this will cause bad user experience. Now, let's talk about escaping. Escaping came about because we don't want to miss actual attack, and we also don't want to have too many false positives. And escaping tries to achieve both properties. Sorry, escaping trying to prevent both false positive and false negative. So instead of throwing away the input, whether valid input or invalid input, escaping only check whether there's a special characters. Then if there's a special characters, it will simply escape. So let's look at how does it do that. So this is the escaping method. As you can see here, the input is wrapped with a built-in function in PHP. And also, this is a function provided for MySQL database. For different kind of database, there might be different kind of escaping function. And this escaping function escape this set of characters, special characters. Now character, break line character, new line character, carriage return character, slash, single quote, double quote, and Control Z. So what happens is that if the attack includes single quotes, like this, The single quote will be escape with a slash. This is known as the escaping character, a character that escapes a special character. So that when the interpreter sees this special character, it will not interpret this as SQL code. Instead, it will be literally interpreted as a code, as a data. Therefore, as a result, since it does not throw away any user input, there is no false positive like whitelisting approach. But on the other hand, we can still have kind of false negative. And let's look at what kind of false positive, false negative can still be there. Let's look at our example here. Assume that the user input is this one, and let us replace this value variable with the value here. The password is this value. Both the username and password is this value. So in this case, the SQL injection attack will not be successful because here, as you can see, this code indicates the opening of a string value, and this indicates the ending of the string value. And once the SQL interpreter sees this single quote, it will not end this string here because now it is being escaped. So this whole thing will be treated as one single string value. Assume that if you don't escape this, what will happen is that this will be treated as an empty string value regarding username. And then the rest will be treated as different part of the SQL query. So in this way, the user code can cause the different kind of SQL query. But with escaping, that is not possible anymore because this code is not being treated as string ending string delimiter. Instead, it is treated as a literal value, and that's why this whole string value will be treated as a value for the username. And the same for the password. So in this case, there is no SQL injection attack because the query syntax does not change. It is still the same. So this will prevent, escaping prevents the attack. But let's look at a different scenario where escaping cannot prevent the attack. So now, let's now assume that the user provides a different kind of input. Instead of using code, let's say the input's like this. Okay, and now let us replace the username with that value, the new value that the user modified, the attacker modified here. Remember, the original query syntax was something like this. It was like this. Okay, now I'm just simply trying to replace the variable with the value entered by the user. So it becomes like this. And as you can see here, none of these characters will be escaped because all of these characters are not considered dangerous character as far as this escaping method is concerned. Only null character, new line, carriage return, slash, single quote, double quote, and control Z will be escaped. So for this value, nothing will be escaped. Even the SQL keyword all will not be escaped. Why is it so? Because although all can be considered SQL keyword, you cannot escape this to avoid false positive, because what if the username is Doki? Okay, so this is a valid user input, but this contains OR. So that's the reason why the escaping does not escape all of the SQL keywords, only certain special characters. So as a result, your query becomes like this. And if you look at this username, this whole value will be treated as a username. And then if you look at the password here, and this will be treated as a numeric value because there's no opening. There's no opening ending string delimiter. That means the value 1 will be treated as the password value for the password parameter. And as a result, what happened is that after that, this all become an SQL keyword, because this is not part of the value for the password anymore, because there's no opening and ending string delimiter. And then in this attack, there is no need to use the single quote anyway. And as a result, this value 1 will be treated as a password value, and then the rest will be treated as different part of the SQL query. So essentially, what happened is that, forget about this part first. Let me just explain about this particular query syntax. So there is two conditions here. One is whether this part is equal, this part will evaluate to true or false. Two conditions. So the first condition will evaluate to false, because assume that the username for this particular user, the password is not 1. So it will evaluate to true, false. But on the other hand, since this is a Boolean OR operation, and as long as this is true, the overall evaluation will still be true. So this is obviously true, and then as a result, overall will evaluate to true. And then it will still result in a successful SQL injection attack. So let me summarize. In this attack, there was no special characters that are contained in this list were used, but still SQL injection attack was successful. And that is a false negative by using escaping function. So if you look at this, all of these methods, there can be false negative and false positives. And that's where bound parameters comes in, a clean solution to the problem, also known as parameterized queries. So let's look at how we can build bound parameters. So this is how we can build bound parameters. Let's look at it. So if you compare, so this is the query that you built using bound parameter technique. And this is the original way of constructing the SQL query. So instead of building a query like this, now we are building using bound parameters. And what is the difference? The key difference is this. So here, in using bound parameters, we are not using any variable here. These are called placeholders. So there is no variables here, simply placeholder only, and everything here is static. There is no variable. It is all static. And this is this syntax, SQL syntax, as intended by the developer. So that means later on, this placeholder will be replaced with the actual variable containing the actual value. But since the intended SQL syntax has been declared before replacing with the variable has no way of changing this query syntax anymore. Those variables will only be treated as data, not as SQL code. And that method is called bound parameters. So these are the details of how such bound parameters are achieved by using built-in PHP functions. Of course, different programming languages will have different built-in functions, but they all serve the same purpose, which is treat the user input as data, not as SQL code. So you can see the difference. This is the original query. Here, the original syntax cannot be told from here because of the presence of variable. Since this is variable, there's no way that this query can be fixed because of the variable here. But here, there's no such variable, and this tells exactly the query syntax that you want as a developer. And after that, let me just dive a little bit. After that, it tells the SQL interpreter that to prepare for such SQL query, and this is the query that I want to execute, nothing else. Only then we bind the placeholder with the variable that contains the actual user input, and also declare the data type of such input. here in this example, user is a string parameter, password is the integer parameter. But that means this built-in function will take care of replacing such user input, but also it will also take care of ensuring that those user input can never modify this query syntax, which has already been prepared earlier. All right, so that is the concept behind parameterized queries. And this is known to be the most secure solution to address SQL injection problem. Having said that, bound parameter is secure, but there are certainly ways for the developer to mess this up. For example, even though this is a way that you should construct a bound parameter query, what if the developer construct a query like this? Okay. As far as PHP is concerned, this is the legitimate syntax. There will be no compilation error. There will be no syntax error. But for the SQL interpreter, as soon as you use a variable here, although when you are only preparing for the query syntax, since there is a presence of the variable, this query is not static anymore. And that's why it is not, that's why it is not sure that this query syntax is fixed, because since this is a variable, when PHP execute this, the variable will be replaced with the actual value. What if the value is something like this again? Then the query syntax will change again. And whatever the query is here, this query will be taken as a prepared query statement. Only after running this, the query syntax will be fixed. But since there's a variable here, the query syntax can still be changed before preparing. So to recap, when you build a prepared bound parameters queries, the developer is supposed to use only placeholder when preparing. Now, only after preparing, the developer is supposed to bind the parameter with the actual variable. Only then there is no way of such variables to go and change the query syntax. Otherwise, if you are still using a variable here, there is a way for the attacker to go and modify the SQL query syntax, and it will still result in insecure solution. So therefore, to summarize, to prevent the SQL injection, there are two kinds of attack: sanitizing and validating user inputs. Sanitizing and validating user input, in fact, they are most widely used compared to bound parameters. The reason is because this can be constructed very fast. Bound parameters, although if you look at this separately, it sounds quite trivial, but imagine there are many kind of SQL queries. Writing, this kind of code can become quite complex. So bound parameters is very secure, but often escaping method is more widely used, and that's why that is a reason why we are still having SQL injection attack until nowadays. But if everybody start using bound parameters in a proper way, not like this, but like this, then we will not have SQL injection attack anymore. It will prevent SQL injection problem. And that's all I want to talk about. We have talked about SQL injection, how SQL injection works, different kind of SQL injection attacks, and defenses against SQL injection. Thank you very much. See you next time.